In the world of programming, data is literally everything. But how do we actually manage it when it's not just a few items, but thousands or even millions of them coming at us all at once? Well, today we're diving into one of the most fundamental tools for that exact job, the array. It's a simple idea, but it's the powerful concept that makes handling massive amounts of information not just possible, but efficient. So before we can really appreciate why arrays are so critical, we kind of need to understand the problem they were built to solve. Let's start with a basic challenge. How do computer programs handle huge collections of related info without just falling apart? Okay, imagine this. You're building an app. Let's say it's a simple contact list. You need to store 100 different names. How would you actually do that in your code? It sounds like a pretty straightforward question, right? But as you're about to see, the most obvious answer gets really messy really fast. Your first instinct might be to just create a separate variable for every single name. You'd have name 1, then name 2, name 3, and you just keep going all the way to name 100. But this approach, it's not just clumsy, it's a nightmare to manage. It absolutely does not scale. I mean, what happens when you need 1,000 names or 1,000,000? The whole system just collapses under its own weight. Yeah, clearly creating an individual variable for every little piece of data is a complete dead end. And that brings us to a really important realization. There has to be a smarter, more organized way to deal with big collections of data. And that smarter way is the array. See, instead of trying to juggle 100 separate, messy variables, an array lets us use one single powerful container. You can think of it like a filing cabinet. Every piece of information gets its own labeled folder, but they're all neatly organized in one place. So what is an array, really? At its heart, it's just a data structure that lets you store a whole list of related things, all under one single name. It doesn't matter if you're using Java or Python or C++, the idea is the same. It's a collection, a list, a container, all rolled into one. Now, arrays have a few core principles, a few rules of the road. First, an array can hold lots of values, but they all have to be the same type, so all numbers or all pieces of text. Second, and this is the really crucial part, every single item in that array gets its own unique position, its own address. We call that an index. And this whole indexing system is the secret sauce. It's why arrays are so incredibly efficient for working with huge data sets. All right, so let's start by looking at the most common kind of array, the one-dimensional array. Now, don't let that name scare you. It's basically just a simple, straightforward list. And making one is a pretty simple three-step process. First, you tell the program what kind of data you're going to store in it, numbers, text, whatever. Second, you give your array a name. And third, you tell it exactly how big it needs to be, how many slots it should have. This little piece of code shows that perfectly. We're saying we want an array that holds text, which in a lot of languages is called a string. We're going to name it cidades, which is just Portuguese for cities. And finally, we're telling the system, hey, set aside exactly 50 empty slots for me. Just like that, it's ready to go. Okay, now here is probably the single most important detail you have to remember about arrays. It trips up almost everyone when they're starting out. In programming, we almost always start counting from 0. That means the very first slot in any array is at index 0. The second one is at index 1, and so on. So if you have an array with 50 slots, the indexes actually go from 0 to 49. So how do we use these indexes? It's super simple. To put a value into the array, you just use its name and then specify the index inside square brackets. So with our cidades array, if we say cidades 0, we're talking about that very first slot. If we say cidades 10, we're targeting the 11th slot. It's just like putting mail into numbered mailboxes. It's direct, it's precise, and it's incredibly fast. All right, so we've got a handle on simple lists. But what happens when your data isn't a simple list? What if it looks more like a grid or a table that has both rows and columns? Well, for that, we can just expand the whole idea of an array into a second dimension. And the difference is actually really simple. It's all right there in the syntax. A normal one-dimensional array uses one set of square brackets. That represents a single list of things. But a two-dimensional array, it uses two sets of brackets. That small change transforms our simple list into a powerful matrix with both rows and columns, just like you'd see in a spreadsheet. Here's a perfect real-world example. Imagine you need to store 2 different grades for 3 separate students. A simple list just isn't going to cut it, right? Because you have 2 categories of information, the students and their scores. This is a job for a grid. A two-dimensional array is the perfect tool for this. And this table shows you exactly how that works. We've got an array we'll call notas, which just means grades. We've defined it to have 3 rows, 1 for each student, and 2 columns for their grades. Now, to get to a specific grade, you need 2 coordinates, the row number and then the column number. So notas of 1, 0 lets us instantly pinpoint student number 2's first grade. It's like a coordinate system for your data. So far, we've only been storing simple things like text and numbers, but the real power of arrays goes way beyond that. Let's explore how they can hold much more complex, custom-made data structures that we call objects. So this is a really important idea. An array isn't just limited to simple little pieces of data. In programming, an object is a way to bundle related data and functions all together into one neat package. This means each slot in your array can hold an entire thing, a whole self-contained unit with its own properties and abilities. Check out this example. Let's say we have an array called vehic, short for vehicle, where every single element is a vehicle object. We can go to, say, index 10 to get that specific vehicle, and then we can interact with that object's own unique properties, like calling a function to get its speed, get velocidad. We're not just organizing simple data points anymore. We're organizing entire functional things. Okay, so we know how to build arrays and how to fill them up. Now let's get to one of their most powerful features, how we can pass them around to other parts of a program, we call these methods, to perform really complex operations on the entire collection of data all at once. This is an absolute game changer. A method is like a mini program or a specialized tool that's designed to do one very specific job. And what this means is that you can hand over an entire collection of data, an entire array, to one of these specialized tools. That tool can then go to work on the whole data set and hand you back the fully processed result. This bit of code here defines a method called ordinArray, which basically translates to sort array. And it's designed to do one thing. It accepts an entire array of integers as its input. It doesn't care if that array has 10 numbers or 10 million. And after that method does its magic, it doesn't just return a single number. No, it returns the entire array, but now all of its elements have been rearranged in perfect order. You pass in total chaos, and in one single step, you get back perfect organization. That's what computational efficiency is all about. So let's just end with this thought. What this all leads to is massive, massive scalability. When you use arrays, the logic you write to process 10 atoms is the exact same logic you'd use for 1,000,000. So what if you could organize, sort, or analyze 1,000,000 pieces of data with just a single command? That's not science fiction. That's the everyday power of organized data, and it's all made possible by the humble array.